All right, folks, so we said today is all about charts. Basically, the reason you use a chart is to see a pattern, and hopefully you'll be able to see the patterns as we go today, and then we're going to write algebraic expressions for them. Okay, so how much is it going to cost you for one hot dog? Okay, how much is it going to cost you for 2 hot dogs? 3 hot dogs? 4 hot dogs? And 14 hot dogs. 24.50. Good. Your calculator probably said 0.5, but make sure you put a 0 on it since we're talking about money. Now, can you tell me how you found out that 14 hot dogs would be 24.50? Savannah? Okay. Somebody besides Savannah, can you tell me how you found out that 4 hot dogs would be $7? Everybody okay with that? Oh, it shouldn't be by H. Thank you, Gage. How do we calculate for 3 hot dogs? Okay, does everybody see the pattern? Yeah? Okay, so write an algebraic expression, meaning there should be variables in it, and it should not have an equal sign. So what's the pattern here? What's going on? What are we doing every time here? Multiplying the number of hot dogs by 175. Well, here I just know that the number of hot dogs is H. So how would you represent that? Good. I'm glad you said 175H. Please don't tell me H times 175. It's proper to put the number first. How we doing? A-okay? All right, so now you should be able to tell me how much 22 hot dogs cost. You are really hungry. How much? $38.50. Tyler, you said you keep getting a fraction? They keep telling you 1/2. Okay, so we're going to need to fix the settings in your calculator. When we're done today, let's try and take care of that, okay? Everybody all right here? Are we sure? Okay, so let's make sure we got some vocabulary down. And some of this is new, and some of this we did on Wednesday, I think it was. Can you tell me what a variable is? Come on, speak up. An unknown number. Remember, these variables are lowercase. Okay. What's a value for a variable? What do you think that means? What's that? I think you're right. I just didn't hear you. Yeah, it's the number that you're going to put in for the letter. The number plugged in for the variable. Now, if I tell you that x is 7, that means you're going to put in a 7, right? Do you leave the variable in there or do you take it out? What do you think? If I tell you x is 7, are you going to leave the x in there and put in the 7, or are you going to take the x out and put in the 7? Yeah, it's substitution, folks. It's like the football game tonight. If somebody goes in, somebody has to come out, right? Otherwise, we get a penalty for too many guys on the field. Everybody understand? You guys alive today? Are we awake? Let's go. You got half an hour. Half an hour. Here we go. Algebraic expression. You should be able to tell me what an algebraic expression is from Wednesday. What does algebraic mean? What's that? Has to have a variable. What's an expression? No equal sign. So this is a mathematical statement with variables and no equals sign. Okay. Well, that's an algebraic expression. What do you think a numerical expression is? It's still an expression, so it's not going to have an equal sign. Okay, Gage? What'd you say? It's going to have numbers. Basically, there's not going to be variables. You're going to have plugged in numbers for all those variables. So you will not have variables. And you will not have an equal sign. Mathematical statement without variables and an equal sign. Okay, so basically it's just numbers and operations. Okay. Now, we're dealing with tables, and if you look at every single table that you've got on there today, all of them have two columns. There's a left side and there's a right side. Everybody good on that? The left side is the input. Those are the numbers that you're multiplying or you're plugging in. Which means, what's the right side? The output. Now, if we want to put this in science terms, if we want to go a little cross-curricular here, in science, it's the X and Y. This left side is going to be the X, and the right side is going to be the Y, but what are they called? It is independent and dependent. Okay, Mrs. Neary will talk to you about that, independent and dependent variables. In math, we call them something different, and we're not going to talk about this now. I'm just going to plant the seed so you see the words, and we'll come back to it later. The input is called the domain, and the output is called the range. Input is the domain, output is the range. Everybody doing all right? We ready to get to it here? Okay, so I need you to read the problem underneath there. It's about Menards. And I need you to label your columns. Don't calculate anything. I just want you to label your columns. Go ahead. And I'm sorry that this graph kind of got cut in half. What do you think, Dallin? What should I label those columns with? Yep. They're both not going to be the same. They're going to be different. What do you think the left side should be? What do you think the right side should be? What are these numbers representing over here? M for miles. Okay, so this side is miles. And then what will we be calculating? What will be the output? No. The price or the cost. Okay, so now I don't actually want you to calculate them. I just want you to tell me how you would calculate. So Lucas, what do you think? If I'm going to go 10 miles, what am I going to have to do? Lucas, what do you think? If I'm going to go 10 miles, what am I going to have to do here? How much am I going to have to pay? Okay, so how much am I going to have to pay from the information they gave me up here? I don't actually want to know the answer. I just want to know what you would be typing in. Is that all we have to pay? You see the $49 upfront fee? Should I add, subtract, multiply, or divide that? Perfect. Trevor, how about for 20 miles? What would you do? Good? Looking good? Quentin, how about for 50 miles? Good. How's everybody doing? Fine? Use your calculator. Calculate all three of those, please. Just put them off to the side. Yep, should have decimals. All right, what are we paying for 10 miles? Anybody? Like that? How about for 20 miles? Even? And then for 50 miles? Okay, so now I want you to look at the pattern that we had here, and can you write me an algebraic expression for m miles? Look at our pattern here in green. Perfect, Mr. Crawford. So now I can do this for any number of miles. I can do it for 72, I could do it for 13. Any number of miles I would plug in there for m. Doing all right? Moving on. Okay. Go ahead and read about the house of cards and see if you can label your columns. Remember, the left side is the input. That's what's changing. The right side is the output. That's what we're trying to calculate. Say that again. Nope. Inches is one side, but which side? What are you calculating in inches? What's that? Don't know. Anybody help? Anybody got ideas? The levels is the input. That's what's changing. The levels is what's changing. How many levels of cards do we have? So then once I know how many levels I have, what would I be calculating? What would that tell me? How high it goes, the height. And like you said before, that would be in inches. Okay, so I don't know about you, but sometimes a picture helps me. And I am the first to tell you that I am not an artist. So don't make fun of my drawings. Thanks. No, it's a house of cards. Just look like stacks of money. All right, so tell me, how would I calculate the height of this thing if I wanted to do two levels? First thing I want to know is, how high is the table? 24. How high is each card? Each of these is 3.5. So if I want to do two levels, how would I calculate that? Good. If I want to go two cards high, I would take 3.5 times 2. Does the height of the table change? No, it stays the same. It does not vary, meaning it should not have a variable on it. Not yet. Don't solve them yet. How would I calculate it for 3 levels? Four levels? Okay, hold on. How's everybody doing? Fine? Okay, Dalton's row, you guys do 2 levels. Braden's row, you guys do 3 levels. Trevor, you guys do 4 levels. Tyler, you guys do 5 levels. And I'll do 11 levels. Okay, go ahead and calculate it, please. Mine is 62.5. Should I put a 0 on the 62.5? No, we're not talking about money, so we don't need to put a 0 on there. Quentin, you got a number for me? Say it again. 34.5, and you guys were 3 levels, correct? What do you think, Trevor? 41.5? Like that? Oh, are you sure it was 41.5? 41.5. Like that? Gage, is that what you got? 41.5? 41.5? I think you guys did the wrong one. This one is 41.5. That's okay. You got the right answer, though. Savannah, you got your answer? You better figure it out. Retype it in. 3.5 times 2 plus 24. You do okay getting that, Braden? Cody, you okay? 38. How about you guys over there? Okay, how we doing, folks? So now that we have this, can you use the pattern to write an algebraic expression for any number of levels? What are we going to write here? How we doing, guys? Are we following okay? Are you sure? Okay, now let's see if you can follow directions because fourth period could not. We're going to skip this next little paragraph, and we're going to go down to where it says another group. Does everybody see that? Okay, so that's where you're going, down where it says another group. Go ahead and read it. No. Okay. There's no chart on this one, is there? Bless you. In fact, they already gave you the algebraic expression. Guys, what's the algebraic expression here? Right there it is. That's how tall it'll be. N still represents the number of levels. Okay. They want to know how tall is the table? From the algebraic expression, can you tell me, from the algebraic expression, how tall is the table? 34, because does the height of the table change? No, which means it should not have a variable with it, correct? Which means the height of the table is 34. And they told you in the directions up there that the cards were 5 inches tall, didn't they? Okay. Finally, what would the algebraic expression be if they added one more level? So if you had this, and I wanted to add one more level to it, but I don't know how many levels we have to begin with, how would you represent that? Plus, how many levels am I adding? Just one, so what am I going to add? Plus 1. Now, when we do this, folks, adding 1 looks like that. But the way this looks is that you're going to calculate this first, and then you're just going to tack on 1 inch to the end. Is that what we wanted to do, is just add an inch? We wanted to add a level, correct? What up there represents a level? What part of this represents a level? No. N represents my number of levels, doesn't it? So if I want to add to a level, I physically have to keep those together and show I'm only adding 1 to the level, the number of cards. How we doing there, guys? We okay? All right, we're going to do one more. We're going to call it a day. Go ahead and read. The first thing I need to tell you is a polygon is just a shape. Okay, a polygon is a shape. So go ahead and read there. See if you can label your columns. So, what changes from a triangle to a rectangle to a pentagon? The number of sides. And the changing is the input. That goes over here. What do they want me to find? The number of triangles that you can make. So we're going to draw this. First thing up there that they tell me is 3 sides. What kind of shape has 3 sides? A triangle. Now they're telling me in the directions that I'm supposed to connect the vertices. What are vertices? Nope. Nope. What are vertices? They're the corners. How many corners do we have here? So they're telling me I need to take my corner and connect it to the other corners. Well, isn't that already done? Okay, so how many triangles do you see? 1. Now I want to do a rectangle. I want to take a corner and connect it to the other corners. Well, how many lines do I need to draw to connect it to all the corners? Nope. This one's already connected. This one's already connected. The only one I need to connect is to this one, right? If I do that, some of you guys are zoning out on me. Get up here. If I do that, how many triangles do you see? 2. Next, we have a pentagon. How many sides does a pentagon have in it? 5. Penta means 5. Kind of looks like a house. Let's just use this top vertice up here. It's already connected to that one. It's already connected to that one. How many more line segments do I need to draw? 2. If I draw 2 line segments, how many triangles do you see? Okay, so now what's the pattern? If I go from the input to the output, what's the pattern? You subtract 2 every time. Does it work for all of them? 3 minus 2 is? 4 minus 2 is? 5 minus 2 is? 3. Does everybody see that? So what's my algebraic expression going to be? Well, I'm not using n. What am I using here? I'm using s. And how many did you tell me we subtract? 2. So my algebraic expression is s minus 2. Now, the reason I ask you this is because if I ask you to do a decagon, which is 10 sides, do you really want to draw something with 10 sides? Not going to be very easy. So use the pattern. How many triangles will a decagon have in it? 8. Wonderful. How we doing, folks? Just fine? You sure? Okay, so you're going to have a worksheet for homework tonight, and I'll pass that out to you now, and we'll get back at it on Monday.